The companies shown here have kindly supported the SPE Thailand monthly technical meeting program for the 2025 to 2026 season. In total, we are supported by 48 companies, and their contributions truly make events like this possible. If your organization is interested in being part of this community, please feel free to reach out to us. And of course, we sincerely appreciate to all of our sponsors for your continued support. Our society thrives because of partners like you. And as of June 2026, SPE Thailand section has a total of 701 valid members, comprising 379 professional members and 322 student members from 4 student chapters, including Chulalongkorn University, Suratnali University of Technology, Prince of Songkla University, and Chiang Mai University. As shown in the chart on the left, our professional membership has increased since January 2026. That said, we are beginning to see signs of gradual recovery. Currently, there are 187 professional members whose membership have lapsed, so we kindly encourage you to review your membership status and, if applicable, consider renewing your membership. In addition, we would greatly appreciate your support in inviting your colleagues to join our events so they can stay informed and connected with the latest developments in our industry. I would also like to remind everyone that SPE Thailand remains one of the largest professional organizations in the oil and gas industry. One of our core missions is to create opportunities for professional engagement, providing a platform that is both technically enriching and socially engaging in a relaxed and welcoming environment, just like today's event. So there are so many reasons to maintain a valid SPE membership and even more reasons to join. I won't go through all of them today as they are already shown on the slide, and I believe that many of you already know since we meet every month. However, it is worth highlighting that one of the key benefits of being part of one of the most active SPE sections in the Asia Pacific is the regular opportunity to network, share knowledge, and connect socially with peers who share common professional interests across our industry. And with that, let's move on to the main highlight of this evening. May we please have Khun Surachai, the SPE Thailand Program Committee, up front to introduce our speaker.
Good evening, everyone. Let me introduce myself. My name is Surachai. I'm the SPE Board Committee. So it's glad for me that to have a chance to introduce the speakers today. I believe that the topic is very interesting. So that's why we see a lot of people today. Even we have the traffic jams and the raining a lot, the heavy raining outside, right? Today is kind of very special that we have 3 speakers from 3 companies together to present one topic. It's kind of the demonstrate the collaborations from our E&P industry. So this is kind of the very special to the event today. So let me introduce our speakers tonight. The first one, Khun Willy, is from the MedcoEnergi. He is the reservoir engineering professional with nearly 2 decades of the experience in the upstream oil and gas industry. As a senior manager, subsurface wells at the Medco, he focuses on the reservoir management, field development, and production optimizations for the asset in Thailand. He has contributed to more than 10 fields developments with the expertise in measure fields development and optimizations. The second one is Khun Siriporn from the Valeura Energy. She is the geoscientist with the over 20 years of experience. She currently serves as the Senior Development Energy senior development geologist at the Valeura Energy, supporting the field development and subsurface evaluation in Thailand. She had led the multidisciplinary teams and played the key roles in the major projects in Thailand and also the international. With the expertise in the reservoir characterizations, reservoir management, and the field development. And the third one, Khun Agil from the SLB, is the business line manager for the East Asia at SLB with the extensive experience in the technical operations and the commercial roles. He drives the business growth and delivers advanced energy technologies across the region, bringing a strong expertise in drilling, measurements, and field operations, along with a global perspective from his international career. So it's time for the presentation. So let's welcome Khun Willy.
Thank you for a kind introduction for three of us. Good evening, everyone. Um, Thank you for coming to this presentation. So not only because of the collaboration, I really would like to present this together because it's less burden for me because we share question and answer later together among three of us. All right. So right. All right, so the topics tonight is about utilizing the horizontal drilling technology that we are using for developing the appraisal mature field in Gulf of Thailand. And for the case studies is coming from two companies. I'm working for Medco, so I'm going to show the case study from Medco, and later on Khun Siriporn will present from the Valeura side, and will be closed by Khun Agil on the how to do it with SLB. All right, next slide, please. Not working. It's working. It's working now. All right, let me start with the Bualuang field, the field that Medco operated in the Gulf of Thailand. So we use a horizontal well to test the north structure in the Bualuang field. So let me give you a context first. So on the right side, as you can see that's a depth structure map. So the bright side is the shallowest one, and going to the dark color is the deeper one. And as you can see from the structure, we develop mainly in the shallowest one where the oil column is bigger in the beginning. You see many horizontal wells there, very congested. And the position of the platform, as you can see that in the blue circle, this one, the main reason of the location of the platforms is because of that's where the crystal parts of the field itself. And along the time, we start production in 2008, and along the time, you can see from the bottom left of the pictures of the slides, you can see that the bright side is the oil, and because we are producing the oil, and it's being swept by the water because we have a strong bottom water drive, and then mainly the depletion, the swept is the only in the the crystal area, and from our analysis, that's the undrained area, which we don't have the wells here, is still there is still oil remains there. So that's we simulate until 100 years, and then the oil still there because there is no wells there. So yes. Okay, now the next question is whether this simulation is true or not is the next question. So how to make sure that this simulation is true or not? We have couple of options, whether we shoot the 4D seismic or whether we drill the conventional appraisal well, so the low angle appraisal well. or we drill it from the platform. We drill a long horizontal well from the platform. So I will show you that options and one by one and see what's the options, what is the best option to appraise this node structure. Anyway, the three key uncertainties of this appraisal is of course the oil present, and then the areal extension and the structural depth, which is very common in the appraisal well. So the well that we are talking about is this well BC01HST1, which planning to drill this location. And as you can see in here, it's gonna be the long horizontal wells. Okay, let me go through one by one. First of all, the depth uncertainties and appraisal challenge. Okay, if we shoot the 4D seismic, what we can get is, there is still remaining uncertainties in terms of the depth, because what we are acquiring is we need to convert the the time to the depth with the velocity, and that's still we cannot get it from the 4D seismic for that area. And the other thing is the structural complexity itself, because it's it's a fluvial sand, and then as you can see in here is the structure is not only it's a very not smooth, and it's coming up and down. And the last but not least is this is we cannot resolve this by the 4D seismic, is because the uncertainty of depth cannot be resolved itself. So as you can see that if we shoot the 4D seismic, the vintage seismic and the new one will result the same. So that's why we eliminate the 4D seismic to appraise this appraisal location. The next one is the reservoir challenge itself. So as you can see from the left pictures, we are in the fluvial depositions. We are having a kind of vertical accretion deposits model actually. So when you have the channel, and then the next new channel is will erodate the old one. And what we can see from the recent condition is it looks like this. So this picture is along the horizontal wells in the past, and this is the periscope image result from this well. The red itself is the oil or the high resistivity things, and the dark is the low resistivity things. And as you can see, the top structure, the top sand is not smooth actually. It's coming up and down, and in the certain part is sometimes is missing. So how about if we drill a low angle wells? If we drill here, okay, we are lucky, we have oil. But if we drill the low angle well in here, we basically condemn the node structure. We drill, see the oil or a small oil column, and then say the oil is not exist in the node structure. So that's why the low angle appraisal well is not our options. So we decide not to do it to appraising this node structure. So now the only options is only the drilling from the our existing platforms and drill the horizontal wells. So this is our strategy actually. So we sidetrack from the existing wells. So original borehole that we choose is directing to the same direction, going to the north. And by doing the drilling from the existing platform, we have a benefit. So we can produce right away after we drill the well and prove the oil is there. And apart from that the long horizontal wells also can able to maximize the reservoir contacts, and we can combine the appraisal and production in a single well. So as you can see in here, you see the strong green stick here and the light stick green stick here. That's basically the target of the production section, that we are sure that the oil's there. And the remaining light green stick here is basically the appraisal objective. So we are not really, willing to complete that one. So that's why we are drilling horizontal well confidently, is, basically to complete until the production section, and the remaining is we are going to use to appraise the north structure. And again, the best data acquisition, as I can is as I go through from slide by slide, is the long horizontal well is the best data acquisition to appraise this north structure. Results. This is the results. This is the periscope image along the well. We are successfully geosteered 1.4 kilometers without any operational issues. This is the profile of the wells itself. As you can see that this is the actual of the well profile, and this is the top structure that we predict before we drill the well. As you can see in here, that we got oil even shallower than what we predict as a top structure. So means that we are successfully appraised that north structure. We found that the depth is shallower than what we predict, and then we can complete the wells itself, because it's all the section is we are having high resistivity oil. And as the result is, if we go to the top right of the chart, so this is the water oil ratio versus the cumulative oil. So less water oil ratio means you have less water and more oil. So what we prognose is the red one here, and what we get is basically the green one. So as you can see that all the green one is below the red one, means that we got more oil and less water from these wells. And again, this is part of our cost optimization. As a good petroleum engineers, what we are like to do is maximizing the value by having more production with the less cost. And we are doing this, we are achieve the cost optimization because we can appraise the new structure without drilling appraisal well, open water appraisal well for that. And we are having directly production from this well, because we are sidetracked from the existing platform. So that's our showcase from Medco. So I will hand over to Khun Siriporn for showing the showcase for Valeura. Thank you.
Can you hear me? Okay. So good evening, everyone. I'm Siriporn Shibano, geologist from Valeura Energy. Okay. Today I will be sharing with you a story about one of our horizontal well that we drilled in November last year. The story is about how we utilize the horizontal well to capture the remaining hydrocarbon in our mature field, Jasmine Gulf of Thailand. Okay, my presentation will be in 4 parts. I start with the introduction of the field, and then I will talk about how we identify the target, and then I will talk about the well planning challenge and everything, and then end with the result. So let's start with the first slide, the overview. I will be talking about the challenge in the field. And there is a Jasmine field. Jasmine is quite an old field. The production started in 2005. And in just like other field at that time, we produce oil out of the deviated well. And in Jasmine, reservoir is quite massive. the main drive mechanism is the strong water support. Then you can imagine, right, that water coning is a big challenge in the field. So they quickly realize it and they start drilling horizontal well in the following year, like 2007, to capture the remaining oil. Since then until now, it's like 20 years. We produce significant amount of oil, and actually we will hit key milestone 1,000 100 million, sorry, in a few months. Sorry, 100 million in a few months. So with that significant amount of oil, you can imagine, like in our inventory now, our target is getting smaller compared to 20 years ago. That's why we have a talk today. So the first challenge is that our target is very small. And the second one-fourth of our reservoir are shallow sand, unconsolidated, and in those reservoirs, they have the high viscosity oil. It's about 40 to 60 centipoint. It's very difficult to produce them. And next one is the subsurface challenge because we are very mature field. So we produce everywhere. We're not sure where the oil remain. The saturation is very uncertain. And the last one on top of all subsurface challenge, we have the complexity of the well collision. In this particular platform, Jasmine Bravo, we have over 50 wells drilled out of the platform. You can imagine the well is everywhere. So drilling a new well out of the platform that already have 50 wells is very difficult. So to that, let's look at the picture. This one is a example of the one of our shallow reservoir. It's about 2,600 feet subsea. It's unconsolidated. And you can see those green lines are the deviated well that drill at the beginning of the field. The gray already abandoned, the green is active. And those horizontal well, you can see that one and that one. It's drilled since 2007. And last year, I just done the PNX in one of those wells in the middle of the area, and we found the oil still there. This is viscous oil, so we cannot produce everything. Even though we have horizontal well optimize the best location, but the oil still remain. So we plan the king well in the middle, but you can see it's in the middle of the jungle of those wells. So that's what myself and Khun Pop need to work, how to get that well drill later. Okay, next slide. This slide I will talk about the one particular well, the Jasmine Bravo 28 site tag 2 that we just drilled. This slide will be about how we identify the target. And let's look at the picture on the left-hand side. It's a time-lapse picture of the map and the information from 2016, 23, and 25. What you're looking at here, the map is the HCPV map, is the hydrocarbon pore volume map. The white area is where we don't have oil at all. The area that we have color is the area that we have oil. And the area that we're looking at is in the yellow polygon, defined by two faults to the west and the east. They are merging together, forming the arrowhead structure pointing to the south. And to the north, over there, is the edge of the sand. So from this picture, that sector in the middle has about 2.17 million barrel of oil. And you can see that green polygon, that is the well that they drill at the beginning of the field in 2016. The well placed at the best location, that is the highest structure over there. And since then, let's look at the production profile here. So the well become online in 2016. It produced about 1,000 barrel of oil and it declined. What we see here is like this is viscous oil reservoir. So water cut developed very quickly. It hit about 90% within 6 months. And we kept producing high water cut 90 until 98 and 99% water cut. around here in 2023. At that point, we produced about almost like 450 MSTB. That account for around 21% recovery. We're talking about 2 million, right? So for strong water support reservoir, we will, if it's light oil, we may expect like 60+%. But here the viscous oil, we expect to recover about 35%. So that means quick calculation, we probably have another 300,000 there. So then another information came in 2023. We drilled that well and it's located there at the green dot. After that production and the well very close to the producer, the oil is still there. Water contact slightly move up, but the saturation still very good at the 35% water saturation. So we said, okay, we have the target. And then how can we best recover this oil? Where should we drill a well to maximize the recovery of the reservoir? So we put two targets, the red one right there at the crest and another one here, high and tight, very close to the fault. And then we are thinking, if we were to drill these two targets with two new wells, it costs us like 5 million each. And if we split that 300, maybe like 200 in the north, 100 to the south, or 150 and 150, that make each target marginal. We like start to think how about the list of each target. When we look at it, the north target, this one, we have the producer right there, right? And the load structure is there. Our target is in the way between the water and the producer. Actually, here is a fault, but it's connect to the big. It's a juxtaposition to a big aquifer. So if our well in the middle, the new well, our target in the middle between water body and the producer, we may have swept in that area. That is the list for the first target. And for the second target, it's very close to the water as well. The distance to water is very close. So if we drill a well there, high viscosity oil, we may cut water very quickly too. So we were thinking to make the well economic, maybe we need to compromise. Let's combine the two targets. But you can see the length. Normally we do that length not exceed 2,000. To combine these two targets, we will have to make it much longer, like twice, almost 4,000. But anyway, we made decision to combine the two targets. And then we go to the well planning challenge. After we made decision to combine the two targets, and then we think next we will drill a new well or sidetrack because we have the original well bore there, right? We can just sidetrack right away over there. We first think about let's do the new well first because with the new well we can put the pump very close to the reservoir and then we can drain as much as we maximize the recovery. But having the new well very close to the existing well there, Khun Pop say no. He cannot put the well, the landing point at where we want. Khun Pop, this Pop, our partner, not you. So that means we need to sacrifice half of the target. The northern target, that is the crest of the reservoir. We don't want to lose any oil, so we drop the new well option. Then we now go to the sidetrack option only while the option that we want to develop. And for the sidetrack option, we can go very close to the existing well and capture everything. And for the well plan, we plan to land there and continue drilling to the south, cross to the other target. But you see at the earlier slide, my target is very close to the fault there, right? But because of this well in the way, I need to compromise the target a little bit by turning it anti-clockwise to make these two targets align. And that's how it look on the cross section. This is where we sidetrack the original well bore. And we plan to drill in a shell, cause a fall, enter the reservoir, continue in the first target, drop to the second target, and flat out. That is the plan. And one more thing that I want to mention, we foresee the problem, but luckily that problem didn't happen. In our around our well here, there's another well right there. Over there, it's on top of our well. It's here on the cross section. This one is our well, and we have that well on top. At the second target is very close to us. During the planning phase, we dropped the well down. That's why we didn't have the collision problem. But during the geosphere, if the structure is wrong, if the structure go up, we will be very close to the existing well bore. That means we will fail the collision. So our plan in my pocket, I plan to use geology to help. So we use geography rule. So we know that existing well is in the shell all the way at that location. And when we steer the well, we said we can manage to get the current well in the sand 100% by using the, what is the name? Deep. Telescope, what is that? Deep azimuthal resistivity to. Sorry, not familiar with that name. So we said, okay, that is our mitigation, but luckily it didn't happen and we didn't use it. So SLV was happy. All right, so now the last slide, the result. This is what we got. So we execute the plan very well. Everything went very well. We successfully drilled the well. And then we got this well, the longest horizontal well drilled in the Gulf of Thailand in November last year. And we celebrating only 2 months. Then Medco go over to us. Perfect. But anyway, now this well is still the longest horizontal with completion to TD as of now. So we still hold the record. Right. Okay. So we claim something. Okay. So a little bit more that I want to touch on is like doing the site tracking the well help us a lot actually. First, we don't have to deal with all the collision above. I think Khun Agil will touch on this, so I will not talk into the detail. And also, make us very easy to land the well. What I want to show you here, when we sidetrack the well over there, and this is the result. Sorry, that picture is little bit is quite small, so bear with me. This is the telescope. Sorry, the deep azimuthal resistivity image. There is image resistivity above and below the well, and is image the contrast. So we know the difference in resistivity. That means different rock as well or fluid. So when we drill this well, this is where we sidetrack at the beginning. Oh, I forgot to mention the color bar. The blue is 3 ohm and the red one, the top one is 50 ohm. So when we sidetrack the well, we drill in the shell. And at this point before we crossing fall, we saw something below that blue and green and we think that is our sand, the target sand. So we talked to our engineer, the geosteering engineer, can you help project our well? We think we see our target reservoir there already. Can you project the well that we can land into our reservoir smoothly, and we want to be about 5 feet below the top of the sand. So the engineer did that and they communicate to DD and then we execute it. And as a result, we enter the reservoir very nicely at the where we want it to be. And it's really very close to original well bore as well. And then in average, this will be about 5 feet below the top as we want. And remember at the beginning, I talked about the risk of being swept in the first target. Here, I think it's swept some, but still, we have still very good resistivity, almost 50 ohm. The oil still a lot there. You can see that this new well is very close to the old well. The old well already produced a lot, but because of the high viscosity oil behavior, it cut water fingering to the well. Still, there are lots of oil remain close to the well bore. And I want to continue a little bit on the geosteering. Remember, we finished the first target. We plan to drop to the second target. Actually, we plan to flat. We think that we can just continue flat out and then we TD the well. But the reality is not that nice. So at this point, the previous structure going up, we think it will be like that, the black line. But in reality, we have the structure going down. So at that point, when I saw the result, I thought, oh, good that I didn't do a new well there at the second target. Otherwise, I will have an uneconomic well already there. So I want to say, like, because of the technology that we can drill a longer well that help us to avoid this kind of risk and not end up with the uneconomic well. What happen if we have to drill 2 new well that cost like 10 million? This well we drill only 3 million. We have 7 million cost avoidance just because we have the right technology at the right time. Imagine if we have this problem 20 years ago. There's no way we can do this. We have to park this, put this in the inventory and wait until the technology available, then we can go there and recover the remaining oil out of the field. And that is end of my presentation. So thank you for listening and I hope you enjoy the story. Agil.
Good evening. Sawadee Yeah, well, two previous presenters shared the problem, and I'll try to share on how we solve their problems. And quoting Khun Siriporn mentioned before, and how we deploy technology, the right technology at the right time. So, and we are in between of the competition with Valeura and Medco, and very proud to be standing here as part of this solution, right? The topic is how we solve the problem and how this mature field complexity shape the drilling technology and practices. So we split into 4 different categories on the technology deployment. Right, the first one is the collision risk, as Khun Siriporn mentioned before, and how we have to maneuver from the condensed, very dense platform, which consists of 50 wells and very complex anti-collision scenarios. The second one is on the challenges on the engineering. This mostly the horizontal wells, all of the horizontal wells. One of the wells is ERD wells. And the engineering drilling is very important on how we solve a lot of issues. And those wells that we were drilling are horizontal wells, where the uncertainty, the minimum uncertainty is very important. Make sure we land right precisely on the reservoir that we desire to be drilling in, right? And once we land, once we are within the reservoir, we want to make sure that we are not only staying in the sweet spot, but to find the sweetest spot of the sweet spot within the reservoir as long as possible. So Khun Siriporn mentioned before about the collision risk, right? This is how it looks like. It's a very dense reservoir platform, 50 wells in one platform, and typically in any traditional wells that we will face anti-collisions mostly on the surface in the area. Anti-collision is like on how we maneuver within the very crowded platform. But for this well with Valeura especially, this anti-collisions happen from the top until the reservoir. So basically, we have to really maneuver since very beginning top and then the reservoir, right? So as a Khun Pop, Khun Cholakon was very heavily involved on deciding the strategy of the coalitions to avoid the offset wells. The strategic sidetrack was deployed or was planned to sidetrack deep, right? Because there is no more space on the surface. So the sidetrack was done in deep, so we have room to maneuver the well to allow us to penetrate the reservoir. So it's very compact, very interesting project with a good cooperation with our customers. This was done through our experience, good data survey management that allow us to to really plan the well carefully. We did the HSE risk assessment to ensure we drill the well safely until we reach the reservoir. So what we in conventional MWD survey was not enough, right? There has to be an advanced survey, gyro well drilling survey that we have to deploy specifically for this area because the anti-collision happened at the high angle, and the gyro well drilling tools typically only survive in the low angle wells, but we have to deploy specific gyro well drilling tools to be able to maneuver, help us provide the accurate information of our well inside the within the low angle wells as high angle wells, more because most of the reservoir is 90-degree inclinations. On the engineering challenges, right? I divided again into four. The first one is in the directional drilling tools, right? So these directional drilling tools, we have to start building the angle with the dogleg of 5 up to 6 degree per 100 feet at a very, very shallow depth. For all the drillers, you might know that the challenge of building the angle, such angle in very shallow formation is challenging. So we're talking about making a dogleg of 5 degree per 100 feet at the TVD of 1,200 feet in general. So it's extremely soft, extremely challenging, and we deploy very advanced and unique RSS, which is not common to be deployed in the region. And we have to be drilled with a very experienced one that has the experience of the field, the one that knows how to work with the technology. And it was configured with a low flow, right? Because the challenge is always to drill with a high angle, and the soft formations is how to avoid wash out your formations. So this technology is very specific that we deploy, and we also together with the Valeura and Medco that we deploy the stick slip reduction tool, right, to ensure that that energy that we transfer downhole, it generates or translates into performance instead of shock, instead of high torque. So we want to ensure that that energy that we transform into a performance and a higher ROP and reduce the torsional vibrations on the BHA, which eventually will improve the reliability of the BHA. On the second one is the casing running, right? There was in the past there was an issue to run the casing, and we did the deployment of the eccentric shoe helped improve the operations of running casing and to land until the bottom. The third one is in the wellbore accuracy, right? I remember drilling horizontal, you have to land the well right at the very accurate TVD. It was deployed was the continuous definitive survey while drilling. Probably know when we drill the well, you take survey every 30 meters or every 100 meters during connections, right? Because we need the more accuracy, we need a more dense survey between the stands. We deploy this one without having to stop pumping. We take, the equipment, the tool took the survey every 10, 15 feet, whichever you program the tool to be working at a certain rate, right? Without stop pumping. Typically in one stand, you got every 100 feet, you get 2. Now you can get more than 5, 7, depending the ROP or the timing. So that really improved the accuracy of the TVD, right? And as I mentioned before, the GWD not only help us maneuver to exit from the crowded reservoir, but also help us improve the EOU. EOU is element for uncertainty. That will also improve the accuracy of the depth and the survey itself, right? On the talk and tracks, again, this well is considered ERD, where the drilling dynamics is important. It was designed to deploy engineered tapper, drill string, and then we pump also lubricants that help reduce the torque by 20 until 30%. On the well placement, now we land the well safely on the reservoir. Now we are already in the reservoir, right? So we're very proud to share that 21 years ago we started the well placement. We deployed well placement technology. But at the time we started with the boundary detections. With boundary detection, it's only one layer, right? I'm not sure if I get. Yeah, this is one layer boundary detection. Then over the time, the technology evolved into a multi-bed directions, and also evolve again to be the bottom one is multi-layer mapping, right? So at the time, the technology was to help you to stay within the boundary. As long as you know that you are within the boundary, it's good enough, right? And then the technology developed and transformed. In 2016, we don't talk about the bed boundary anymore. We changed the terminology into reservoir mapping. We map the reservoir, not only helping you stay within the boundaries, but also help us land the well precisely before you enter the reservoir, right? So in this technology, in the first three technology on the left, typically the pilot hole was required. Right, the pilot will require, the TVD, your marker, and then we land the well based on the pilot hole. That is where the failure came from, right? When you know to deploy technology where you can land the well without a pilot hole, you're saving 2-3 days of drilling the pilot hole. So this technology on the right, really as SLB, I want to mention the brand, but I'll hold myself not to mention the brand. But on the right is to help you land the well precisely. So this technology is a look around, like 10 feet above the desired TVD, you will know that that is your top reservoir, and that is where the assurance of DVD comes, right? Because before we enter the reservoir, we already saw it, and then we didn't land precisely. And then 2023, we started not only knowing where we are, but we know exactly which one is the sweetest. I'm saying so sweeter reservoir, right? And we improve the high definitions data to characterize the reservoir, and we have more options. We know which one is sweeter to go into the red reservoir. So red means it's a very resistive, and the blue one is the conductive. And then we deploy this technology on those two wells with the Medco and Valeura for the last 3 wells that I will summarize in the end. And the last one is the 3D real time. So all the picture that we saw before shared by Khun Siriporn and Khun Willy was mostly 2D, right? So we only talk about the roof or we talk about the base, right? So the latest ones that we are seeing, we are evaluating for the further deployment is the 3D. So you look at not only up and down, but left and right, and seeing the reservoir as a column. So you see left and right, up and down, and help our operator to really evaluate the economical of the well by looking at as a column, as a 3D. So it's probably in the future that we need to evaluate this one to improve the understanding of the reservoir. And again, this we'd like to. I'm very proud to, as a SLB team and the entire team, that within 3 months we have 3 achievements, right? As Khun Siriporn mentioned, in November 2025, Jasmine B20 STH broke the record as the longest completed horizontal well with lateral of nearly 4,000 feet, right? And probably it's still the longest when you talk about the completed well, right? This is the longest. And the milestone, the achievement is that we have, as a team, we have Valeura to save the $7 million saving. And in January, 2 months after, Khun Willy and the team broke the record to drill the longest horizontal well, lateral 4,600 feet. And I really remember during when after the Medco achieved, they congratulate each other. It's very warm to read the email from Khun Book to Khun Willy about the achievement of all the team members, and we really proud deep from my heart that SLB is in between these two emails. Right, so it's very warm. The competition is very healthy. Then in March, Khun Book came back with another record and Valeura Energy. So you know, again, it's now it's the record still stands, right, as the longest lateral sections in the Gulf of Thailand. But we see probably we have to wait. Medco of Valeura will break its own record. So this milestone establishes a blueprint for future marginal field, right? In the development of the Gulf of Thailand. But beyond that, we all know that our mission is to provide access to energy to fulfill the demand of the country. So thank you so much and have a good evening.
Yeah, thank you very much for the three speakers, Khun Willy, Khun Siriporn, and Khun Agil. Really appreciate it and really heartwarming my heart as well that we can see such a great collaboration in Thailand industry. May we give our applause for our three speakers? So we will not let you go yet. So it's time for Q&A. So if anyone has a question, please raise your hand and microphone will reach you. Please state your name and your company as well.
Hey, my name is Leung from PTEP. I am a driller. So I just wonder, can you touch a little bit on the completion? This well is going to be a producer well, right? So when you have two target reservoir in the same horizontal section, how you producing strategy? That is the first question. And the second question is, since one of the speaker mentioned that the most of horizontal has a reservoir in almost 90-degree inclinations. So is this horizontal producer gonna be a future of this field or not? Or we still going back to the conventional deviated well? Thank you.
Okay, I think the big question is who's going to answer?
Okay, let me answer the question number one about the completion. So, yeah, as you know that the horizontal well, if you imagine the hose, and then we make a long hose and we put, many holes, and then we flow the water, you can imagine that the hole that near to the source will flow more compared to the one in the toe. What we call in the horizontal wells is a heel more compared to the toe. So I think what both companies did is so this is in Jasmine in Valeura. They use the autonomous inflow control device to ensure that the distribution of pressure along this horizontal segments is equal. So the flow is almost equal from the heel and the toe. So if you can imagine that in the drawing, so this is how the completion looks like. So we let the lateral become the open hole, and then we put the open hole screen here with many packers, open hole packers, and then we put the way that we put the packers is to make the segment, and then we put the AICD or any kind of valve in order to control this production. So we would like to ensure that these long horizontal wells can contribute from the heel to the toe. So that's my short answer. I believe same with the Valeura as well. Yeah. And second question. That's horizontal well is our past and also the future. Yes.
It is because like for Valeura energy, our reservoir, if we have deviated well, it cold water very quickly in order to maximize recovery of the reservoir. The horizontal well is the best technology that we need, especially the shallow reservoir that is unconsolidated. If we produce with deviated well, it will produce sand a lot, and the well will be not okay. Okay. It is. It's a key technology that we need.
Okay, thank you. Any further questions from the floor? Oh, Khun.
Excuse me, Kun Philip always has questions. My first commentary is I feel like I'm in a locker room where we're competing for how long our horizontal length is, which is a little concerning because I guess it's all about the result of the well. And I'm sure what you guys have all achieved is some excellent results from these wells. Congratulations. So, anyway, I have two questions. We talked a lot about collision tonight, and we have a lot of experience in this room. And how big a deal is collision in reality for you drillers, Kumbuk and team? I think you've all hit wells accidentally, occasionally on purpose. And what is the real statistical risk around collision and the forces that are involved and what could happen? That's question number one. And question number two is for Schlumberger. If we want to do these wells at 3,500 meters, similar or longer horizontals in granite, when and how can we do them for geothermal?
Okay, Philip, thanks for the question and allow me to help the answer. Kemawat, drilling manager from Valeura Energy. Basically, we never plan the well to hit any well. And Valeura, we try to factory a little bit that we can try. But we customize the well one by one. And I actually look at the well plan by myself and with the team. Single well that we're going to drill because of the challenge that geologists give it to me. If they confirm that we have the oil, we will drill. So we look at the well and do the rig assessment well by well, and we develop the way to make sure that the well is not collide with the existing well. Some of the well we I don't want to say we barely touch, but we never plan on that one, right? And we have the rig assessment. Some that we have to develop the plan to actually exit from the body of the sand, where we don't have the marker. If we might hit some well, we try to avoid it. Somehow we drill in the sand body, get out from the sand, and actually have the locking tool to help us navigate into the shale body. When we cross over the well, come back into the sand again. sometimes 2 times in a well. So this technique we call the georeference and not registered yet. So you always open to, yeah, it's not no trademark from us. You are more than welcome to use it. And I think the key is we never plan to let the well hit each other. We work with the business partner carefully, work with our geologist team. We always have a two barrier to make sure that we don't hit each other. Either leap of uncertainty, as number one. Number two is a geological marker, which we call the georeference technique. The second one, I think I might have to let the business partner help me.
I think they already discussed for a while.
Yes, it took us 2 minutes to align on the answer. So the first one is in the implementation of the application of the granite, right? We are now in the middle of the operations where we are drilling granite. We're drilling 80 degrees. It's a multilateral wells, not in Thailand, in the region that we deploy resistivity image, not the geosteering, but we are doing it. So it's resistivity image in the OBM. We have that technology to give you a fracture because they're looking for fracture, and you see you evaluate all the fracture. That's the first one. The second one is geothermal, right? So geothermal is very specific and unique reservoir. We deploy this deep azimuthal resistivity horizontally in Europe, is France and in Germany. We have that experience. I don't have the details, but we know in the announcement internally that there is a deployment of this technology. So if the question is, can we do it? Yes, we can. Thank you very much.
Thank you.
My name is Pakon from PTTP. I have few questions. The first one is about the what would be the recommend minimum thickness of the reservoir that fascinating you to drill a horizontal well? And also is really depends on the accuracy of the tool as well, right? So I start one by one, or I ask all those three questions that I have.
Okay, so probably I cannot answer the economical of the well, right? Whether it's economical or not to drill 1 meter, 1 feet reservoir. But this tool is the OD is a 7-inch, right? And we don't talk about the minimum, but the maximum we have two kind of technologies. First is a shallow detections. The maximum is the first one is between 10 to 12 meters. But again, it came with it depends on the formation contrast, formation resistivity, right? But in average, the one that is multi-boundaries, it give you 10 meters, right? 10 meters boundary. But this 10 meters, I know it's shallow, but it gives you a very good vertical resolutions, meaning between your reservoir and then the boundary, you can see exactly the stinger in between. So it's 10, 12 meters. So there is another technology which we call the deep azimuthal resistivity. They can give you a boundary of 40 meters, 30, 40 meters. Again, it depends on the formation resistivity. We have to do simulations. But the 30, 40 meters is to give you multi-boundaries detections. First, if you want to know any other boundaries below your current reservoir, or the important one is on the oil-water contact. It's also obviously very important information for our subsurface team. So yeah, the maximum, the tool capability can go up to 30, 40 meters for the deep one. But you are interested for not so thick reservoir, but you want to know the vertical resolution better, then we have the tool that can go 10, 12 meters boundary detection. Yeah.
So if I would like to drill slim hole 618, you have a tool as well, right?
Yes, those wells 618.
All right, okay.
So for 618, we have 8.5, we have 12 quarter, we have.
All right.
Okay. Because the implementation of the 12 quarter tools is not only for the horizontal, is to avoid the pilot hole. So when you drill 12 quarter, you know where you land. Depends on your casing strategy and the formation, and then preparation of the formation. But yeah, this 12 quarter is there to help you land the well. It's a look around, right? You know what you see on the there over there, then you want to land exactly where you are. Yeah. Thank you.
Thank you. Thank you. My second question is about the TD criteria. Says you, of course, you're not drilling the well by intention of beating each other, right? The longest, the one will win, right? You have to have some certain co-op for TD. So it's purely by economic or uh-huh.
Yeah, I think that's a
Actually, I have the last question, but I let my boss ask first.
Oh, okay.
ไม่ตอบเลย No, I have no question. Go ahead.
Okay. Yeah, good question. Actually, the TD criteria is for our case is we have development sections and the appraisal sections. For the development section, we have a sure development length from we already calculate how much the effective horizontal lengths, because we don't want to jeopardize the wells, right? Once we reach a certain length, is already economic. So that's how we decide the TD for the development section. So it's really straightforward actually. However, for the appraisal section, that appraisal sections, that our TD is really it's a decision pre-drill decisions. What I would say is we already agree with the drilling team. So the subsurface and the drilling team already agrees that we are going to drill this for appraisal sections and let the subsurface to geosteer until reach that one. So to be honest, it's a pre-drill decisions for appraisal sections.
I can answer from Valeura as well. So for our development well, we do the simulation pre-drill. So in our reservoir, we have the RE to do simulation to see what is the most optimal length for the horizontal well to drill to maximize the recovery. So the decision is pre-drill. That's how we lock it. And another thing is when we plan the well along well, we have our engineer, during engineer and completion, run simulation as well. If we can get enough weight to TD or not for the completion. If we reach that limit, we will not go beyond that because we cannot run completion anymore. So those are the criteria that we use.
Help me. Let's go on from PTT, please. So, I mean, actually, I'm very happy that I never been to the SPs for several years. I would say like that. But when I come back here today, I get forced by this guy together with these guys to come here, and then you should come to see. One great thing that I see is the collaboration among the operator together with the business partners, come up with some solution. The one thing that I realize is I'm from the old school man. I'm an explorationist. I don't know about the techniques that you try to mention a lot, but I saw this one since 2013 when I was in Perth, right? Actually, I have a few questions, but before that, I would like to say something. I truly speaking, they have a school of thought, right? You see the factor models that we do in the Gulf of Thailand, of Felix, that everyone do it. But you try to show something that you are beyond. I don't know that how come. And this is a super success. That's why when he asks about it, how thick of the reservoir, this is the first thing that I really need to know. But he asked already, I don't need to ask anymore. Because I asked in the table already that how thick of the reservoir you can do it, right? Later on, Bo have to answer me. My question is, I don't care about the thick of reservoir. How you confident of your seismic data or even your modeling that you do? So which technique that you use? I'm truly appreciate that you use this kind of thing, to plan the well 1.5 kilometers. How come, man?
how you trust Khun Bob, how you trust SLB, how you trust I mean, this, you have to tell me how, right? This is a collaboration among you guys and the business partners. What the technique and how you believe in your tools, right? And working together with the Joe Stilling, right? And do the well, 1.3, 1.4, 1.5. Future, you're going to give 2 kilometers, right? That you told me. Longer than that. How come, man? So that is the first thing that I really need to know, right? Technique that you use, how you confident, right? To do so. The second thing is, this kind of thing that I realized you mentioned about you worry about the water coning, I don't know about your reservoir south, but any concern on the gas cap or whatever, right? Because we used to handle both the gas cap and water coning, and this one is look like we no mention at all about the Georgia itself about the gas cap. So that's why this is a second question that I really need to know, right? And to steering itself, how far that can you do, right? This is another interesting thing that I really need to know as well. When I heard from Nong Bo mention, oh, you can go very far, no need to do 2 wells, just only 1 well enough, right? And you can manage in terms of the commercialities, leading me to think about a lot of things, right? So just let me know about the limited of the technique itself, right? Just showing how far. Or you want to say that if you have money, you can go. I need to hear as well. Right? A few questions that I have, and I truly appreciate again when we are together that you share this kind of technique among other operators together with the business partners. I'm truly appreciate, and I hope that the next time I can join this kind of event again, if you are invited, right? Right. Thank you. Okay, please.
So the first question about the data that we use, seismic we use PSDM, we have the inversion, but nothing perfect. I would say we made mistake and we learn from it. So we actually drill a well. Actually, I show you that one. The second target, our depth is long, 20 feet deeper than what we predicted. And the well is still economic because we have all those risks identified upfront and we access the risk and put the mitigation. Another one about the simulation, right? Every model is wrong. Everyone know this. So we didn't get the right model at the beginning. We keep updating all the time. When we get new data, we update it. When we get new performance, we update into the reservoir. We get PNX, and then we give to our simulator. We keep updating all the time. That's why we getting closer, and our uncertainty is smaller. That is the first question. I answer you, right? Okay, what is the next question? I forgot. The second one is the gas. Okay, this reservoir in particular, we don't have gas problem, but we do have reservoir that we have gas, the gas cap. And how we deal with it, we use the same, that AICD, autonomous info control device, to prevent gas. I don't know if the correct word or to prevent or not, but it helps balance the flow along the lateral section, slow down. Correct me if I use the right word or not, to prevent the gas coming to the well. We have some reservoir that we do deal with the gas cap. Yeah. Rely on the technology as well, that AICD. Yeah. 2 questions and okay.
Okay. Thank you for the questions. Our limitation is actually up and down, right? On the layer itself, 10 meters, 12 meters, 13, 40 meters that I mentioned before, right? But how far the longest is the limitation is not from the LWD tool. The longest well in the world is 15,000 meters, 50,000 feet. It's a well drilled in Abu Dhabi, right? Yeah. So we deploy that technology, and the limitation typically is not the LWD, but the drilling limitations. Your drill pipe, your torque, whether you have enough big rig to drill a well, your drill pipe, basically the design of the drilling itself. But then in terms of data, the challenging about the data is this is real time, right? You drill 15,000 meter, 50,000, and you put the MWD there to make sure your real time data goes up. And we enhance the technology to ensure that we can deliver the data within 15,000 meters of the deep well. And yes, we have the solution for that. So the limitation is not the LW, but more towards our drillings. It's a drill pipes, your top drive, your rig, your tubular, or your torque. Basically, it's more towards the drilling. But the LWD, there is no limitation to drill the lateral sections. Thank you so much.
Okay, thank you very much. Of course, we save the best for last. Students, now it's your turn. Any question from the student? You got to have one. I told you already. Okay, introduce yourself first.
Okay, I guess it's me. Good evening, everybody. Good morning, guys. My name is Taifa Khap Klamsong. I'm a petroleum engineering at Chulalongkorn University, and now I'm doing an internship at Northern Gulf Petroleum. Okay, and my question is, okay. Out of curiosity, I want to know, how do you decide whether to prioritize during the geo steering? Whether do you decide prioritize the hitting sweet spot or avoiding collision? How do you decide?
It's what all. So when we plan the well, right? Which one is more important or higher priority between hitting the sweet spot or collision? I would say sweet spot first, but we cannot avoid collision. That is given. When we cannot, we like Khun Book just explained, we want to be in a reservoir where we know that is the best. But if we have collision, we avoid it. Like Khun Book just explained, if we want to be in the sand and then in the sand already is a well there, we get out of the sand and avoid and come back. So with the technology, we can do that now. So we still prioritize sweet spot, but we have to avoid collision. Yes, that's. Thank you.
Thank you, Kap. Okay, thank you very much for all speakers. So may I have Khun Kasian on the stage to give the token of appreciation to our three speakers. So Khun Siriporn, Khun Willy, and Khun Agil, please come to the front. Take a picture. Yes. Okay, thank you very much.
Okay. It has truly been an honor tonight to have Khun Willy, Khun Siriporn, and Khun Agil with us as our guest speakers, sharing such an insightful topics and valuable competitions and expertise. I'm sure we all learned something new this evening. And then to share a quick preview for our upcoming meetings. We will meet again on 20 August for SPE monthly technical meeting. The model that builds itself, agentic AI in geoscience modeling from rockfall dynamics. And then we will have our SPE Thailand season opening and ENP Awards announcements on 24 September 2026. Please don't miss these sessions. We look forward to welcome many of you again. And this SP Thailand ENP Awards 2026, the project submission has been closed. Please stay tuned for the finalist, winner, and runner-up announcer during SPE Thailand season opening in September. And I would like to highlight the SPE Patron and SPE Referral Program. This program encourages members to invite the colleagues, friends, or industry peers to join the SPE community. And of course, SPE truly recognizes and appreciates your efforts for members who help grow the network, as shown on this slide. So if you enjoy being part of SPE, please help us spread the word and invite your colleagues to join as well. The stronger our community becomes, the more valuable it is for everyone. And this for the International Petroleum Technology Conference IPTC 2027 will be held in Bangkok, Thailand from 24 to 26 March 2027 with PTTEP proudly serving as the host organization. While we call for papers has now closed, opportunities to participate as a sponsor or exhibitor remain available. This is an excellent platform to showcase your organization, engage with industry leaders, and connect with professionals from across the global energy sector. We look forward to welcoming you to Bangkok for this premier industry event. And our neighboring professional society, the SPWLA Bangkok chapter, will also be hosting their next meeting 1 week after next on Thursday, 30th of July. If you are interested in their technical topics, please feel free to check out their website and consider attending their meeting as well. It's always great to see collaboration within our industry. And finally, here are some SPE Asia Pacific upcoming events taking place within our region. Take special note of event during week of 5th to 6th August. There is an Asia Pacific Dealing Technology Conference and exhibition in Bali, and upcoming IPTV in March 2027 in Bangkok. So please stay tuned for more information about that. And before we move on, I'd like to take a moment to share how we can stay connected with the SPE Thailand section. There are several convenient ways to reach us and keep up with our events and activity. You can visit our website at www.thaispe.organization for the latest update and information. You can also follow and like us on Facebook. Just search for SPE Thailand section or @SPE Thailand. We are also active on LinkedIn and we have official line account as well. It is very simple. Just scan the QR code here as shown here. I will leave it for 5 minutes to make sure everyone already scanned and then I will move on. I'm just kidding. Okay, I hope everyone already scanned and then I will move on. Okay. So, and also we also have the YouTube channel that everyone can watch the record from the SPE monthly meeting for each month on our YouTube channel, SPE Thailand here. And you can scan it as well. And now we come to the one of the most exciting part of the event, the lucky draw. Okay, so please, Willy.
I think you know the guy.
From PTTP.
Oh, Thanakrit คุณธนกฤษ
Willy, give to him.
So we have the Starbucks card with unknown amount. You got to check it out yourself. Congratulations ครับ
ใครครับ
This is probably unacceptable. คุณรามัดอุตโม Valeura Energy ได้ Yeah, we hope we have VR or something to watch the the next thing to look at each other. By chance, man, by chance.
Congratulations to our winners tonight. Okay. So this brings us to the conclusion of our program for this evening. Last but certainly not least, I would like to express our sincere appreciation to all our sponsors. Your support goes far beyond funding this monthly technical meeting. You are truly the driving force that keeps our community active, connected, and move forward. Please kindly approach to our sponsor here. Yeah. And on behalf of the SPE Thailand Board of Directors, thank you very much for joining us tonight. We hope you have a pleasant evening and we look forward to seeing you again at our next meeting. Thank you and safe travels home. And kindly note that all the bar downstairs tonight is 2 for 1. Hope to see you guys downstairs. Thank you.